Here is a summary of a handout that was done in class. A block sitting at rest on the floor. Normal force on the block is 3 newtons. Find the mass of the block. The point of these problems in class was to emphasize the usefulness of what I call net force equations. To figure out unknown forces, the process is to start with a force diagram. And we have that here. And we draw it, normal force up, and it's given that that's 3 newtons. Gravitational force down, we're not told what that is. We might know what it is if we understand Newton's laws, but we do know that gravitational force equals mass times the gravitational field strength, which we learned about last week, and that's how we get mass into this equation, into this problem. Next step is to do a net force equations. First, the sum of the forces in X is 0 because there are no horizontal forces. So that's one set of net force equations, which is trivial. For Y, it's this right here. It's the normal force up plus the gravitational force down. And then we can actually fill in below. We know because the object isn't moving that the sum of the forces in Y total are 0. The normal force is a plus 3 newtons up. That's given. That's the unknown gravitational force. Just do algebra on this equation to find out that the gravitational force must equal minus 3 newtons. We could have figured that out knowing that these had to be balanced forces. But this shows how net force equations can do that for you. And when it's not obvious, these are how it's going to get done. And then lastly here is just to do what the question asks, is figure out the mass. And we start with that relationship between gravitational force and mass, and put in what we know and calculate the mass to be 0.31 kilograms. The next problem on the handout, as a boy, 65 kilogram mass, he pushes horizontally against the wall. The wall pushes on him with a force of 100 newtons. Draw a force diagram and include all the forces on the boy and determine these 3 things you see here. Here's the work for that. Again, there's our force diagram to start. That's the first step we'll always do. And then the net force equations. Horizontal forces, there are some this time. And same process as above, write the net force equation with symbols. Put in the numbers where you can, you leave a symbol where you can't, and solve for the unknown. Friction force must be positive 100 newtons. Because the normal, this is the normal force on the boy by the wall. That's the wall pushing on the boy. It's a normal force. And that was given to be 100 newtons. And since it's to the left, we say that it's negative. So when we put it in the equation, that means the friction force must be positive because it's to the right. And for the Y forces, here's that work. It's the normal force up, floor on the boy, and the gravitational force down. The normal force we don't know, and the gravitational force we don't know, but we know that that equals mass times gravitational field strength, so we put that in here. Next line down, there's the mass, there's the gravitational field strength. And direction matters in the equation, so it's a minus 9.8 because that's a downward force of gravity for every kilogram of mass. This product here gives minus 637 newtons. So when we solve for it in this equation here, the normal force is positive 637 newtons. So we could put that in here, 637 newtons up. This is 637 newtons down, and we have 100 newtons to the left and 100 newtons to the right.